So if line is parallel to any axis, then directly you can take its distance as difference between the coordinates x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. That is the distance between. So now we got PQ. PQ is what? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. 1 root 14 plus 2 root 14 is 3 root 14. Both the sides we got 3 root 14. So therefore clearly welcome to the session, dear students. Today we'll go ahead with the problems of introduction to 3D, that is, we'll study distance formula. So now, derivation of distance formula. Let us derive distance between 2 points. In order to derive distance between 2 points, some basics I'll teach you. Suppose, if I take 3 dimensions, so you know 3 dimensions means what? X-axis, Y-axis and Z-axis. So in 3D, we should represent 3 axis system, and point of intersection of all the axes is origin. Very interesting is suppose I'll take this is y length y1, this is y length y2 from origin. So if I take 2 points, say A and B, the length of this AB is difference between y2 minus y1, because here to here y1, here to here y2 minus y1 means if line is parallel to any axis, the length is difference between the coordinates of that axis. So now this line is parallel to what axis? Y axis. So the length is difference between y coordinates. Suppose you have a line like this. This line is parallel to what? Z axis. Suppose here Z1, here Z2. So now suppose this is C and D. The length of CD is Z2 minus Z1. So if line is parallel to any axis, then directly you can take its distance as difference between the coordinates. Now coming to this, let us derive distance between 2 points. If I give you 2 different points, suppose if you have a point A and another point B, in 3 dimension point is represented as x, y, z coordinate. x1, y1, z1 is one point and x2, y2, z2 be the other point. Now you can find distance between these 2 points using distance formula. So what is AB? Distance between A and B. Distance between A and B is root of difference of x coordinate, that is x2 minus x1 the whole square plus difference of y coordinate y2 minus y1 the whole square plus z2 minus z1 the whole square. So this is the distance between 2 points. x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. That is the distance between 2 points, or we say distance formula. So now we need to derive this. Let us derive this. So to derive, first we should take 3 dimensions. So I'm considering coordinate system. Say I'll take x-axis, y-axis and z-axis. Say this is x-axis, this is origin, this is y-axis and this is z-axis. So now we'll take 2 points which are present in 3 dimensions. So that's why I'll draw this as a cube to consider this. Now let us consider to represent 2 different faces and draw. This is a point P which is in the behind face, and this is a point Q, this is in the front face. So now we need to find distance between these 2 points. We need to find distance between P and Q. For that extra construction, we'll consider one more triangle. Say I'll join this triangle, I call it as QA, Q to A. I'll join the diagonal, and also let us consider this as N, the other points. So now this diagram is important. So now we have 2 points, one is P, the other one is Q. So we'll take the coordinates of P and Q. So we say consider 2 points. What are the points? One is P, and the P is with the coordinates x1, y1 and z1. x1, y1, z1, and Q is another point with x2, y2, z2. So we have taken 2 points, one is P, the other one is Q. So now we'll join PQ, comma QA and QN. Now you can see two different triangles. One triangle is AQN, the other one is PAQ. For both the triangles, just we'll apply Pythagoras theorem. Here this is x1, y1, z1, this is x2, y2, z2. Now we'll apply Pythagoras theorem. So now from triangle, I'll take the first triangle. I'll take from triangle AQN. AQN is 90 degrees here. So opposite to 90 degrees is hypotenuse. So in this AQ is hypotenuse. All of you know Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square is equal to sum of the other two sides square. So AQ square is equal to AN square plus QN square. AN square plus QN square. Call it as equation 1. Then we have to take triangle PQA. From triangle PQA, again let us apply Pythagoras theorem for this. If you apply Pythagoras theorem, hypotenuse is PQ. PQ square is equal to PS square plus AQ square, or AQ square plus PS square. Call it as equation 2. So now dear students, I have taken two triangles and applied Pythagoras theorem. Here again, this, if you take, this is 90 degrees. Between these two, this is 90 degrees. That's why opposite to 90, PQ will become hypotenuse for this triangle. So hypotenuse square is equal to PQ square is equal to PA square plus QA square. I have written. Now you know AQ square. What is AQ square? AN square plus QN square. Now substitute equation 1 in equation 2. So substitute this equation in this. That's it. Means write the value of AQ square. So now substitute equation 1 into. If you do that, equation 2 becomes, what is equation 2? PQ. PQ square becomes, in spite of AQ, you can write AN square plus QN square. AN square plus QN square. I am writing AQ square. AQ square is value is what? AN square plus QN square plus what? PS square. Plus PS square or AP square. So now this is PQ square. I will substitute this. What is PQ? PQ is equal to root of AN square plus QN square plus PA square. Now we need to observe. First I will talk about AN. See, observe in the diagram AN. This is the line AN. AN, if I stretch, it is parallel to what? OX, x-axis. AN is parallel to x-axis. AN in the diagram is what? Parallel to x-axis. It is parallel to x-axis. Here we have x-axis. So therefore, AN length will be difference between y coordinate, x coordinates. AN is x2 minus x1. Why? Because this point P is at, so point P, this is at a distance, its x coordinate is x1 and N, sorry, where is AN? This AN. A is having x coordinate as x2, N will have x coordinate as what? X1. So x2 minus x1. Since AN is parallel to x-axis, length of AN is what? X2 minus x1. Difference of x coordinates of the point. And QN. So you observe the diagram. QN, this is the line QN. Can you see QN? QN is parallel to what axis? OZ. OZ means what? Z axis. QN in the diagram, QN is parallel to Z axis. If it is parallel to Z axis, so QN length will be difference between Z coordinate. Z2 minus Z1. So QN I can write Z2 minus Z1 the whole square plus PA. P to A. You can see P to A, this is a line parallel to what? OY. PA is line parallel to OY or Y axis. So PA is parallel to Y axis. So it will become Y2 minus Y1 the whole square. Now we need to simplify this. So now we got PQ. PQ is what? Root of x2 minus x1 the whole square plus y2 minus y the whole square plus z2 minus z1 the whole square. So now therefore we got distance between 2 points. Therefore distance between PQ is what? Root of difference of x coordinates. So x2 minus x1 the whole square plus difference of y coordinates, that is y2 minus y1 the whole square plus z2 minus z1 the whole square. So between any 2 points, you can find the distance using the distance formula. Now we'll start with the exercise 12.2. Find the distance between the following pair of points. The first pair they gave 2, 3, 5 and 4, 3, 1. So let us consider, we'll solve the first problem. A is equal to, I'll take 2, 3, 5. I call it as x1, y1, z1. And I'll take B. B is the second point, that is 4, 3, 1. I call it as x2, y2, z2. Now you find AB. AB is the distance between A and B, that is x2 minus x1 the whole square, plus difference of y coordinate, y2 minus y1 the whole square, plus z2 minus z1 the whole square. Now substitute it. So that is root of x2. What is x2? x2 value is what? 4. Here we have 4. 4 minus 2 the whole square, plus y2 minus y1, 3 minus 3 the whole square, plus 1 minus 5 the whole square. Now simplify this and get the answer. Now AB is equal to root of, so 4 minus 2, what is 4 minus 2? 2, 2 square, plus 3 minus 3, 0 square, plus minus 4 the whole square. Simplify this further. So it will become 4 plus 0 minus the whole square is plus. Minus 4 square is 16, root 16 plus 4, root 20. Root 20 can be written in terms of a perfect square. I can write 4 into 5, that is root 4 into root 5, because you know root 4 is perfect square, 2 root 5. The distance is root 20 or 2 root 5. Same logic we apply for second problem. Second problem they gave coordinates. What are the coordinates? Minus 3, 7, 2 and one more is 2, 4, minus 1, 2, 4, minus 1. Call the first point as x1, y1, z1 and call the second point as x2, y2, z2. Now apply distance formula. Call it as mn. What is distance between m and n? Root of x2 minus x1 the whole square, plus y2 minus y1 the whole square, plus z2 minus z1 the whole square. That is root of, what is x2 minus x1? 2 minus of minus 3 the whole square, plus 4 minus 7 the whole square, plus minus 1 minus 2 the whole square. So it will become 2 plus 3 the whole square, plus minus 3 the whole square, plus minus 3 the whole square under root. So now 5 square plus 9 plus 9. Minus when you square it will become plus. So that is root of 25 plus 9 plus 9, 34, 34 plus 9. Root 25 plus 9, 34, 34 plus 9, 43. Root 43 units. I hope all of you understood this. So just we applied distance formula to find the distance between them. Now show that these points are collinear. They gave 3 points. They want you to prove they are collinear. Collinear means what? The points are lying on same line. If 3 points are on the same line, suppose if A, B, C, if they are on the same line, AB plus BC should become equal to what? AC. Means sum of any 2 sides should be equal to the length of the third side is the assumption. So now what we'll do? So using distance formula, we'll try to prove they are collinear. Now to do that, let us assume, let A is the first point, A minus 2, 3, 5. And take B, B is the second point, 1, 2, 3. And take C, C is what? 7, 0, minus 1. Apply distance formula, find AB, BC and AC. Longer side should be equal to sum of other 2 sides. So we'll see. First find AB. How to find AB? Again apply distance formula. So call this first one as x1, y1, z1, second one as x2, y2, z2 and apply distance formula. What is distance between 2 points? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Further simplify. 1 minus of minus 2 the whole square plus 2 minus 3 the whole square plus 3 minus 5 the whole square under the root. That is 1 plus 3, 3 square 9, 2 minus 3 minus 1 square 1 plus 3 minus 5 minus 2 the whole square becomes plus 4, root 14. You got AB as root 14. One of the side, one length you got root 14. Now you find BC. Let us find BC. Again apply distance formula between B and C, between these two. That will become difference of x coordinate 7 minus 1 the whole square plus 0 minus 2 the whole square plus minus 1 minus 3 the whole square. 6 square minus 2 the whole square minus 4 the whole square under the root. So 36 plus 4 plus 16 under the root. Root 56 it will be. So now you got 56 times root. Yeah, that's it. Now we have one in terms of root 14. Check whether it is divisible by root 14. AC. Finally, we'll simplify that also. We'll find AC also. What is A? Minus 235. This is A. And C. What is C they gave? The last point, 70 minus 1. Apply distance between these two. Root of x2 minus x1. 7 minus of minus 2 the whole square plus 0 minus 3 the whole square plus minus 1 minus 5 the whole square. 7 plus 2, 9. 9 square is 81 plus 9 minus 6 the whole square, 36. So it will become root of 90. 90 plus 36, 126. See, dear students, AB is root 14, BC is root 56 and AC is 126. So first we have to check whether they are all divisible. So now can I write AC as 3 times 14 or 9 times 14 nines are to 126. So this is 3 root 14. Now I wrote AC in terms of root 14. Call it as 3. Now because everything is in root 14, I'll write this also in terms of root 14 BC. BC 14 fours are. So 4 into 14 is 56. I'll write 2 root 14. This is 2 root 14. Root 4 all of you know. So now we got BC also. Call it as equation. So call this is 1. AB is 1 root 14. BC is 2 root 14. Equation 2. And this is 3. From 1, 2 and 3. 1, 2 and 3 you can see. So this is 3 times root 14. That is 2 times. This is 1 time. So I can say AC value is equal to AB plus BC. Because AC is 3 root 14. And the other two, AB. What is AB we got? AB is just 1 root 14 and the other one is 2 root 14. 1 root 14 plus 2 root 14 is 3 root 14. Both the sides we got 3 root 14. So therefore clearly AC is AB plus BC. Means if I draw the line, A to C length is same as A to B plus B to C. This plus this gives you this whole line. What is the conclusion? Since AC value is AB plus BC, the given points, we assumed them as ABC, given points are collinear. Or what? Collinear. They lie on the same line. They're all collinear. So when can you say points are collinear? We can say points are collinear if the length AC is same as AB plus BC. Means longer side should be equal to sum of the other two sides. Using distance formula, we can prove 3 points are collinear. Collinear means what? Points lying on same line. I hope all of you understood this. I'll see you in my next session. Thanks for attending. Thank you.